This is one of the Sudokus that Gordon Royal and his team at the University of Western Australia collected as part of their research into Sudokus. It's rated extreme. One way of judging the difficulty of Sudoku puzzles is by the methods that are required to solve them. And for this puzzle, ordinarily, the most advanced methods would be required. Things such as aligned pair exclusion or discontinuous alternating nice loops. If you don't know those methods and think you might not learn them, you don't have to feel that you can't solve a Sudoku like this one, because it can actually be solved using just one simple method. That method is known as cross-hatching. The idea behind it is that if there's a number in a row or a column in a certain block, it cannot go in that row or column in any other block. So there's a 1 in the left-hand column in that center left block. That means it can't go in the left-hand column in the block below it. Similarly, there's a 1 in the top row in that lower right block, which means it can't go in the top row in the lower left block. It can only go where shown. By the same token, since there are 5s in that row and that column, the 5 in that center block can only go where shown. Since there's a 7 in the left-hand column of that block, it can only go where shown. And the further step that we're going to take is to consider places where a number can go in a limited number of cells in a block. Not just one, but different possibilities. So since there are already 2s in the darkly shaded row and column, and there's an 8 taking up a cell, we know that the 2 in that block can only go in the lightly shaded cells. So in which one does it go? We try them to find out. Suppose the 2 goes there. Through cross-hatching, we can get more 2s, and we don't know in which of those 2 cells the 3 goes in that block, but we know it has to be in that row. And so we can use that row for cross-hatching and find the 3 there. And what we discover is that now there's no place for a 4 to go in that block. That means that the 2 cannot go where shown. It has to go in one of those 2 squares. Well, let's try this one. Again, with cross-hatching, we can fill in more numbers. The 3 has to go in that row, so we can use it for cross-hatching. And what we discover is that the 3 cannot go anywhere in the right center block. All of those rows and columns are taken. So the 2 cannot go where shown. It must go there. So this has been pure deductive logic. We knew that the 2 in that block had to go in one of those 3 lightly shaded cells. If it couldn't go there, and it couldn't go there, it had to go there. So we've gotten one number. So what does that get us? Well, actually it gets us the rest of the numbers in the puzzle. We'll be able to use cross-hatching to fill them in, and along the way we'll notice some enhancements to it. Again, the 3 we know goes in that row. Now, we can see that the 1 has to go in that column because all the other columns in that block are filled. So we can use that information for cross-hatching and know that the 1 cannot go in that column in the block below. It has to go there. Similarly, the 7 must go in that bottom row in that block, so it can't go in the bottom row in the far left block. And we can see that a 7 must go in that column in the top left block, so it can't go in that column in the bottom left block. So putting all of that together, we see the 7 goes there. So cross-hatching can be a very powerful tool. Now in some cases we don't even have to do cross-hatching. We can see that the 9 is the last number left to go in that cell. Similarly, the 7 goes in the last cell that's left in that column and in that block. So we solved a Sudoku that was rated extreme using just one simple method. And this might make us ask, well, why then was it rated extreme if it didn't require those advanced methods? And if you're interested in that question, please see the comments on this video.